So, what you will need to do, the only thing you actually need to do in line 10, as usually, replace this portion of the code between quotation marks with your working directory, and that's it. You shouldn't do anything else. This is the only thing you need to do. Just work in my file. And I give you like 1 minute to do it. Anybody needs more time? Say something. Okay, so setting up working directory, and then we import data. And again, since you already have the code, you just click on this triangle. Oh, okay. Okay. I guess we just do it like the old-fashioned way. That's weird. And we all know how to do it the old-fashioned way, right? Oops. So we go to File, import dataset, and we remember it's Excel file, right? So from Excel, browse, and feed data final. And this fascinating thing about changing double to numeric. State is obviously numeric. Okay, numeric. Numeric. By the way, I think I understand what happened. Did anyone just click on this triangle and have been able to import the data? Anyone? Because I think I understand what the problem was. In the RMD file and data file are in two like different like folders. But we can do it old-fashioned way. Okay, numeric. Okay, numeric. And the last variable you do is uninsured. Do not do STLDI. Okay, it's numeric. Yeah, basically uninsured 2017, and that's it. You don't need anything else. And we copy paste it. Oops. We import it. And we place it here. And again, I saw people like making this mistake. We need hashtag in front of view. And we save it. Did everyone imported the data? Anybody needs more time?
You do numeric with everything
Yeah,
that has double.
everything is numeric except for name of the state.
Yeah.
But again, we only need like the first like 10 variables. So uninsured 2017 is the variable. Okay.
Sorry, you said everything is numeric besides the initial for the state?
Yep, yep.
Do we leave that as double or?
If it's a character, it's a name. Let's have a look at this. S- State is like a word, so make it a character variable. You see? You guys see my screen, right?
Yeah.
Okay, good. And then here, what I'm doing next in lines 57, I'm installing new package. Since again I already have one, what you need to do, you need to delete hashtag in line 56, right? And then you run it and install it, and then you put it back. And okay, I give you a few moments to do it. We need this package PLM for this data set. This is the package for setting data as panel data. Anybody can tell me the difference between cross-sectional data and panel data? No one? Ben, please save the class.
What?
The difference between panel data and cross-sectional data.
It's panel data. Everything in cross-sectional data is just, one cross-section.
Yeah, and panel data has data on a bunch of years. So we see what we have here in this data set. We have data on like share of young adults imputed, poverty level imputed for like a bunch of states, for like all states, and we have this data for 2014 until 21. So when you see like a bunch of data for particular like unit of analysis, in this case it's states, and this data is for a bunch of years, again in this case from 14 to 21, this is a panel data. Anybody needs more time to install the package PLM? And by the way, when you look at the data, this is a format of the data when it's not panel. And when we click on P data, you see what happens here, right in the left. We have this, which creates kind of connection between uh, observation, right, and a year. Again, observation and a year. Observation and a year. So when we apply PLM package to data, it creates a data which is set up for panel data analysis. And we use panel data analysis to see like how things like change over time. Okay, and then, oops. And then we run a linear regression model. We need this line 70 to get rid of scientific notation. And then we have code for linear regression in line 72. So the way code works, first we create an object, and again it could be anything like it really doesn't matter. Uh, then we have this arrow sign. Then we have LM, which indicates a linear model. Then we have round brackets. And then the first object um, is a name of the variable in the data set. And that variable is a dependent variable. So when you are writing a code for linear regression model, the first object after this round bracket is your dependent variable. Then we have this. Can somebody tell me how this thing is in English, like this thing?
That's called a tilde.
Tilde. Okay. Then we have tilde, and then we have our independent variables. So in this case, the post variable is, let me show it to you. And again, what I like about R and like programming in R, you can actually look at the whole data. So this variable post, this stuff is like about paper I published a few years ago, so I kind of like remember it. So this variable post indicates when term policies have been in effect. And since we have data from 14 to 21, we have zeros when term policies on like on like healthcare and short-term plans in particular have been in effect. And then we do like plus signs to separate our independent variables. So we have this variable share of young adults in each state imputed. Does anyone know what imputed means? No one? Okay, imputed means is that okay, let's look at share of young adults. I remember when I created this data set, some data was missing for a few years. And the way you do imputation, you take values for like 3 previous years, you calculate the mean, and then you like do this mean like below, insert that mean below. And then we have um, share of uninsured people in each state in 2017. Then we have median state income adjusted for inflation. Then we have comma, and then we have a name of the data set. So whatever you have in your line for linear regression, it must correspond to like the variables, the way they are like with the name of the variables in the data set. You cannot just, the liberty you have is how you're going to name the object with the results of your linear regression. This is the only liberty you get, but all other stuff, names of the variables, they must be exactly the same. They appear in the data set. And we run a regression model. Does anyone need more time to run a regression model? We just click on triangle. Okay, say something if you need more time. No? Okay, so when I ask you in the problem set for Wednesday, interpret the results of linear regression, what I'm looking at, I'm asking you to interpret adjusted R-square number, and the way the adjusted R-square number is interpreted, uh, 37% of change in this particular case. Like, okay, let me tell you like the general version and then more specific version. And again, when you do problem sets, you need to be specific. So general interpretation is 37% of change in dependent variables is explained by independent variables in our model. The specific interpretation would be 37% of change in premiums is explained by presence of Trump policies, share of young adults imputed, uninsured rate, and median state income. This is a specific interpretation of adjusted R square. And then you're going to interpret coefficients. And, oops. Okay, can somebody tell me if post variable presence of Trump policies in healthcare is statistically significant or not? Anyone? Ben, what do you think?
Hmm. This doesn't look too crazy to interpret.
Yeah,
Uh,
post variable in this regression model, is it statistically significant or not?
um, given that the probability is something like 1 millionth of a percent, I would say, yeah, probably.
Yeah, it's statistically significant for um 99% like level. That's
Mhm.
uh, and in terms of so again, when I ask you to interpret the results, first you interpret R square, you say percentage, in this case 37% of change in premiums is explained by our independent variables, and you like list the names of the variables, and then you are going to interpret coefficients for variables. So when you see, and our studio, it gives you a hint. So you see significant codes. If you have like three dots, it's like 99% confidence level significance. So it is significant. You say post variable is significant, but then the second step you need to do, you need to interpret coefficient itself, and coefficient is in this estimate column. And since we already know that the nature of our variable is let's see if we can look at it. Where is it? Oh, it's like data set is too big. Um, but I said it before. Our dependent variable premiums inflation adjusted for inflation. So since we know what the nature of our variable, it's just dollars, right? Premiums are measured in dollars. Uh, Interpretation is in years when Trump policies have been in effect, the premiums have been higher by $166 than in years when Trump policies have not been in effect. This is how you interpret coefficient for the model. Any questions about interpreting regression results? No questions? Okay, I keep moving. And the last thing we are going to do, remember I showed you PowerPoint where we are checking for heteroscedasticity. And the way it works, first you create an object, and again, it could be any object. You can name it anyway. Then we use arrow sign. Then we use command residuals. Can somebody say, if I run this code, what will happen? Like in terms of, will I be able to run this code? And I can give you a hint.
It won't run because you changed the name to I hate stats.
Yep. So what we need to do, and again, I am lazy. Oops. This is my approach to coding. Ben probably despises me. Oops. Okay. Oops. Yeah, I think it should work. Yep. So, can somebody interpret this plot? Do we have heteroscedasticity? And again, let's go back to interpret the plot. Oops. Do you see my screen? So if there is no pattern, there is homoscedasticity. If there is some kind of pattern, there is heteroscedasticity, which is a bad thing. Oops. I'll go back. Ah, okay. Okay, thank God. So again, look at this plot. Do we have homoscedasticity or heteroscedasticity?
Hetero.
Yep. So the problem site assignment will be you run the plot if there is and it means we in this model, since it's like again short version, but I think even my proper model still have this issue. In this model, we violated the assumption for errors to be random, and we have a pattern and we have a heteroscedasticity. We didn't run the perfect model. That's about it. Any questions about this?